Energy density is the amount of energy stored in a unit of volume or weight. The difference between the two can be significant. For example, liquid hydrogen at minus 253 degrees Celsius has a volumetric energy density of 2,600 watt-hour per litre, but its gravimetric density is of 39,000 watt-hour per kilo. Whilst hydrogen has a high gravimetric energy density, it requires more storage space. This implies thus that to have the equivalent energy content of 1 kilo of hydrogen, you will need to store 15 litres of it. When looking at the requirements of transport regarding supply, refueling and autonomy, this can become very complex. So, what's the energy density of transport fuels? For example, gasoline has a gravimetric energy density of about 12,200 watt-hour per kilogram. Liquid natural gas has 15,200 watt-hour per kilo, and ethanol, a common biofuel, less than half of it, with 6,100 watt-hour per kilogram. Regarding their volumetric density, the differences are smaller with gasoline at 9,700, liquid natural gas at 7,216, and ethanol at 7,850 watt-hour per litre. So, we would need just under 4 litres of hydrogen to have the same energy as 1 litre of gasoline. This implies that you'd either need a larger fuel tank or travel shorter distances, or new technologies would have to be developed to safely compress the hydrogen. And what about some alternatives? Gaseous hydrogen has the same gravimetric density as in liquid form, 39,000 watt-hour per kilo, but a very, very low volumetric density at just 405 watt-hour per litre. In the case of electric batteries, their gravimetric energy density is about 1,200 watt per kilo, with a corresponding volumetric density of 300 watt-hour per litre. As we can see, comparatively, liquid fuels have the highest energy density, with gasoline showing great values both in volume and weight. This allows drivers, pilots and ship captains to travel further and longer with a comparatively smaller amount of fuel. That's why oil-refined products have been fueling our transportation on land, air and sea for more than 100 years.